Chapter 1 is all about taking the experiments that you designed in Chapter 4, collecting your data and analyzing it. So we're going to start with categorical data and work our way up to the numerical data, calculating the mean, the standard deviation, and things like that. So to begin, we've got some definitions that I think you can read on your own, like the definition of statistics and the definition of data analysis. That's just a fancy way of saying, take your data, organize it, display it, summarize it, do some calculations, and then apply it to a year conclusion. With every experiment, like we talked about last chapter, you've got an individual, whatever's described by the data, and some variables. That could be an explanatory variable, a response variable, and now we'll investigate you can have even more variables than that. There are two types of variables in general. You've got a categorical variable, which is anything that could place your individual into categories or groups. That could be something like color, age, age group, not age. That could be your income level, your gender, anything like that. That would be a categorical variable. Then you've got your quantitative variables, which is anything that is measured or calculated about the individual. That could be time, like how fast you run the mile. That could be your actual income, not your income range. That could be your height, shoe size, things like that. Anything that's a quantitative measurement about the individual, that's a quantitative variable. So a variable can have many different values, and when you show your variables in a table or graph, we call that a distribution. So it tells us what variables you've got and how often it has that particular value. So for example, the Acura RL car has 22 miles per gallon. So you've got a variable and a value of that variable, and in fact miles per gallon is a variable itself. So the one we care about is the miles per gallon. So if we wanted to compare the miles per gallon across the different car brands, we would want to look at a distribution of all these miles per gallons. And so I would plot, in this case on a dot plot, all the miles per gallons and compare how they're spread. You can see the lowest miles per gallon is 14 and the highest is about 33. So by graphing it, you're able to see this distribution of all of the miles per gallon. You can explore all the variables by themselves or try to see a relationship between the variables. So for example, we have our graph, and then we can support the data in our graph with some numerical summaries. That just gets a little more specific, such as mean, standard deviation, how many data points you have, and so on, which we'll investigate later in this chapter. So let's look into categorical variables a little more. That's where you have all of your people or your individuals into groups or categories. In this case, we've got a frequency table and a relative frequency table. A relative frequency table and frequency table are basically the same thing, except one has percents and one has the actual counts. In this example, you've got the format of a type of music and how many stations play that type of music. And so you've got your values and your variables, and then you've got the variable is the format, the type of genre of music. Each value is each different category that something could be placed in. And then you've got the counts, how many stations play that type of music. A relative frequency table, on the other hand, shows the percents, and that can sometimes be helpful when you have varying numbers of things. So it wouldn't be as helpful to know that 1,000 out of 13,000 stations play adult contemporary. It might be easier to just say 11.2%, because then if you collected data, say from a different city maybe, or a different country, and they had a different number of radio stations, let's say we were comparing Canada and the United States and their radio stations, it wouldn't be as helpful to just show the counts, because maybe there are a whole lot more radio stations in general in the United States than Canada. So instead we would show the percents, and that would be easier to compare the two distributions. Now let's look at quantitative variables for a minute. we'll come back to this later in the chapter, but I want you to understand the difference between these two variables because they will come up sooner than later. A discrete variable is anything that has gaps between it. Think like you're stacking books or you're stacking boxes. You're not going to have 1.25 books stacked on a shelf. So it's anything that's countable. That could be how many of something, the number of cats that live in your house, the number of siblings you have. Without getting into too much detail, how many siblings do you have? You don't necessarily have 1.25 siblings. And a continuous variable then would be something that has no gaps in between it, like time. It doesn't just magically jump from 1 a.m. to 2 a.m. It's every second and minute and millisecond in between. And so it's continuous. Your height over time, you don't just jump from 5 feet to 6 feet tall. You gradually grow from 5 feet to 6 feet. I always think of the mercury in one of those old-fashioned thermometers. You see the mercury rising across the degrees. Sometimes this can be confusing because when we record temperature, we only write one temperature, and then we record another temperature, and then we record another temperature. But we're just writing down single rounded values. In general, though, it's a continuous variable. We talked a little bit about frequency tables and relative frequency tables already, so if you want to pause the video here to get a better definition, you can absolutely do this. Here's these same frequency tables and relative frequency tables. Now we're going to take those tables and turn them into graphs. We're going to start by turning them into a bar graph. So a bar graph displays the categories in a categorical variable, all the values of the categorical variable, and their counts. And we're going to look at something called a histogram a little bit later in the chapter, and you'll see the difference between the two in a second. They almost look the same. The key thing you need to know about a bar graph is there is space between the bars. You cannot join the bars together. Between the adult contemporary music and the adult standards music, there's space. And along the y-axis, you've got the counts. Now, this particular graph did not say counts on the side, and if you're just saying counts, as long as the title says that, it's good enough not to label your y-axis. Along the bottom, we didn't label that it was stations either, because it has the categories there, so that's enough. And you can look on the bar graph how many of each type of music is displayed. If you have a relative frequency table, that gives the percents, and you'll notice that that percent adds up to about 100%. Of course, with rounding, you're not always going to be exactly at 100%, but we can make a pie chart with that. So you always want to include a key with all the different colors or patterns of a pie chart, and then you want to have the percents displayed. So this is good to see which one dominates and which one is less frequent. There's some things to look out for when you're doing bar graphs and pie charts. You don't want to make it too fancy or frilly. You don't want to use things like smiley faces or hamburgers when you're making your bar chart. Just use regular old bars and make sure all of the bars are equally spaced apart. It can be misleading if one bar is wider than the other because it might make it look like one has more value than the other. The bars themselves have no quantity. They just need to be the same width so you can show that they're height. The only thing we're measuring is the height. So beware of a pictograph, and that's what I was talking about, where you stack hamburgers on top of each other to represent the bars. And make sure the scales are even. You always want to start at 0 and scale your bar graph, the y-axis, appropriately. Now let's look at things when we have more than one variable. If we want to compare two categorical variables and maybe see how they're related or not related, we would put them in a two-way table. So it can describe two categorical variables and organizing their counts in rows and columns to see where they match and where they don't match. Here's an example. You've got two variables here. You've got the gender, male and female, and then the chance of getting rich. So we've got our totals along the margins here. In the bottom right corner, you've got 4,826. That's the total number of people in our study. Then at the end of the female column, you've got the total number of females, and the end of the male column, the total number of males. On the inside of our table, those are called our conditional frequencies and our joint frequencies. So for example, almost no chance joins with female at 96. So 96 is a joint frequency. Your conditional frequency would be if I only wanted to look at just the female column, I'm basically taking away the male column, and that would be a conditional frequency because I would only be looking out of the females. What's your chance of getting rich? And then you've got your marginal frequencies. That's where you only look at the totals. In a marginal distribution, like I just said, you're only looking at the totals. You're looking at the margins of your table. So the total number of females out of the total number of people. So you always use the data in the table to calculate the marginal distribution. And you're going to leave this as a percent or a decimal before you move it to make it a percent. And you're going to use only the row and the column totals. You can use this to make a graph or a display of the marginal distribution. So we calculate all the percents here, where we've got all of the row totals over the overall total. And we can plot that in a bar chart. So we've got all the categories along the x-axis, and then the percents along the y-axis. A conditional distribution is where you've got the denominator changes from the total to one of the category totals. So like I said, a female total or a male total. We're going to talk more about these bar graphs and segmented bar graphs in class and do an activity with those. But here's a little bit of what they look like. If you have a conditional distribution, then the denominator changes. For example, if it's out of the males, that's a condition. It's only out of the males. What's your chance of getting rich? So our denominator changes from 4,826 now to 2,459. I can calculate those percents and do the same for the females, and I can put them together in what's called a segmented bar chart. Again, we will talk about this some more when we talk about segmented bar charts and mosaic plots in class. But the good thing about segmented bar charts, real quick, is that you can see an association between two variables. For example, if I wanted to see if the chance of getting rich was associated or dependent on your gender, I could look at these two graphs and see, look, for example, the purple, almost certain. Are they close to the same percent? Or the red, good chance. Are they close to the same percent? Of course, these two bar charts are pretty close together, so it's up for interpretation. But you could say there is an association or there is not an association. In this case, since it looks like the purple and the red and the yellow are somewhat close to the same size, I would say there's probably not an association between your gender and your chance of getting rich, because it doesn't matter whether you're female or male, you would have about the same opportunity, no matter which category you're in. So like I said, you can make a determination if there's an association between two variables. If there's a large difference between, let's say, the red categories, then I would say yes, being male greatens or lessens your chance of becoming wealthy by age 30. Or if the yellows were really different in size, then there would be an association. It doesn't mean that they are associated as in they look the same, but it means does it matter whether or not you're male or female to get the same outcome? If being male and being female gets a completely different outcome for a category, then there is an association. Your gender influences your chance of being wealthy. But be careful. Even though there's an association between two categorical variables, it can be influenced by other variables lurking in the background. You always want to think about what other variables could influence your data.